Hey everyone, so fixing the clock. There we go. I have to keep track of the time because if the videos get too long, then YouTube won't let me upload them. So again, TGIF is the last class of the week. So we made it through a first week, I guess, so to say. Again, if you're not, as a reminder, if you're not on Lumen Learning, please, get access to it. If you are having trouble, don't be afraid to email me. Some people have. I did change the link so that when you click on the link, the homework and quiz website link in Blackboard, which takes you to Lumen, it opens up in a new window. I don't know if that will make a difference, but I think for one student it actually did, so I figured it wouldn't hurt to set it up that way for everyone. So again, please get access to Lumen Learning. I do expect homework to be assigned. Not tonight. I think homework is supposed to be assigned tonight, but I'm going to change that. It won't be assigned until the 1st, February 1st, that is, which is Monday. And then homework won't be due. That homework won't be due until Sunday before midnight, the following Sunday, that is. All right, so, that said, let's get started with the lecture. Okay, let me just okay. All right. Okay. All right. So last time, remember, let me see, can everyone see it? Yeah. Okay. So last time what we were working on were monomials, right? Remember, these terms look like this, which were a times x to the k. And remember, the a here was a non-zero constant. Excuse me, it's a constant. It could be non-zero or it could be zero. If it's not zero, right, then the k, which is a non-negative integer, is the degree of the polynomial, of the monomial, excuse me. Now, if you happen to have only a, so there's no variable there, then we say it's a monomial, but it has degree 0. A has to be non-zero, though. Okay, like 4, 8, 6, whatever, okay? Any non-zero constant is a monomial of degree 0, okay? If you do happen to have if you do happen to have the variable here, these are monomials in the variable x. If you do happen to have x here, then the exponent of x, this k, is the degree. And if a happens to be 0, though, then the monomial has no degree. It's just 0, and 0 has no degree by definition. And for monomials, as we saw last time, we can get to polynomials, but let me just do some more examples first. X to the 4, right? That's a monomial. It's a monomial of degree 4. Remember, if the coefficient is 1, we do not write it. Okay? That's just a convention people take. It's not technically wrong to write it, but people just don't do that, I guess, for convenience. Okay? Yeah?
I had a question.
Yeah.
When you have a number like x to the 4th, for me personally, it's just easier that I put the ones in front of it, or if it's just x and I put the 1 as the exponent. Will I get that marked wrong?
No.
Okay.
No. I mean, I know technically you're not supposed to, by convention, people may not do that, but if you happen to do that with me, I'm not going to take points off.
Okay, thank you.
You're welcome. Good question. Okay. All right, so let me keep going. Wait, are there any other questions, actually? Okay. Again, 5 here is a monomial, right? This has degree 0. It's a non-zero constant, okay? So it's degree 0. 5 times x to the 8, though, okay? This, however, is a monomial of degree 8. This time, 5 is the coefficient, and the 8 is the degree. What's the exponent, but it's also the degree. I threw this one in here, I guess, kind of for fun, so to say. This is actually not a monomial because remember, the exponent of x has to be a non-negative integer. Pi, remember, pi denotes a decimal, 3.14 something. So this is actually not a monomial. Okay? Again, the k here has to be a non-negative integer. Okay. Also, again, I did email the notes, so you should have the notes, everyone, in your email inbox. All right, so we have that. And this is just, again, something else I just wanted to remind you of. It was on a slide from it was in the notes from last time. Again, if two monomials, this is what it means for them to be like terms. Basically, they have to be in the same variable and the same degree. And if they're not like terms, we call them unlike terms. Like terms, you can add and subtract. And you do that by just adding or subtracting the coefficients. And you do that by adding or subtracting the coefficients. Okay. Again, that's just really by definition. I know it looks like we're factoring out. It's not really factoring out so much. It's just specifying the rule. So, okay. Now we get to polynomials. And a polynomial, again, it's really just a sum of monomials. That's really what it boils down to. I should say a finite sum because although it's not Calc 2, because I know in calculus you can consider infinite sums. But anyway, you're just adding some monomials together. Essentially, that's what a polynomial is. And it turns out you can always write it in what we call, well, in this form, which is called standard form. You can always write it this way in what's called standard form. Basically, you could see the exponent of x, which is the variable, it's decreasing as you read this from left to right. It's decreasing as you read it from left to right. Okay, now here's some more terminology. This might be kind of strange. Okay, again, if the coefficients are 0, we really don't write the terms. And really, this is just saying, this is being formal, but really this is just saying the biggest exponent of x is the degree of the polynomial. That's the degree of the polynomial. Okay? So that's what the degree is. And the term where that happens, again, really, I guess we're assuming a sub n is not 0. If it were 0, the term would not be here. We wouldn't write it. The term where that degree occurs, where the biggest exponent of x is, we call that the leading term. That's just that's the leading term. And the coefficient of that is the leading coefficient. This term here, there's no variables here. We call it the constant term. We call it the constant term. And also, again, let me just remind you, the exponents of x, the variable, they all have to be positive integers, or I guess technically 0, although if it's 0, we really don't write it. But basically, none of these exponents can be negative integers. They have to be positive integers. Okay. All right, so let's look at some examples. So here's one. Here's a polynomial. What's the degree of this thing? It's degree 3. That's the biggest exponent of x, right? The 3. This term is where that degree occurs, where the biggest exponent of x is. This is our leading term. The leading coefficient is 6. The constant term is 2. Okay, the constant term is 2. Good. Okay. Here's another example. We have a polynomial here of degree 5. Right? It's degree 5. Why is that? The biggest exponent of x here is 5. This term, where the exponent is, right? That's the leading term. This term, then the coefficient here is the leading coefficient. It's 4. Right? The coefficient of that term. The 1 is no variable here, right? It's the constant term. And here's another one here. What's the degree? 6. Highest. That's the biggest exponent of x. What's the leading term? That is, well, it's this term because that's where the biggest exponent of x is. And the leading coefficient is also 12. The constant term is 0. It's really not there, so we could just say it's 0. Notice also that each polynomial here is in standard form, right? As you read it from left to right, the exponents of x are getting smaller, right? So they're in standard form. Good. All right. Okay, so let's do some more examples. First, let me stop the recording.